Alright, so we are going to use trend lines to make predictions on scatter plots. So our first example right here, we have boat sales at Dustin's Marina are given. So there's a table of values, and so they took those order pairs and then they plotted them. Okay, and we learned last Thursday this is a trend line. Alright, so the side is a constructed scatter plot using the data with a trend line, or remember it's just a line of best fit. Okay, where most of the points are. So we're going to use the line of best fit to make a prediction about boat sales in week 9. Okay, so week 9 is right here. So if we use that trend line, where do you think boat sales, what do you think the number of boat sales would be? So if this is week 9, we're going to go all the way up to the trend line. And what is this point? About how many boat sales? Yeah. 16 boat sales. That is it. Questions? Alright, so if we look at our next example, okay, we're going to use the table, and let's go ahead and plot our points. And this table shows the number of new members to join the outdoor club. So at day 1, how many new members? 3. Day 2, 6. Day 3 is 4. 3, 6, and 4. Okay, so we constructed the scatter plot. Can we draw a trend line for this? No. No. What type of, what is this?
No association.
Yeah, there is no association, no correlation. So the number of days and the number of new members have nothing to do with each other, okay? And so that means it says use a line of best fit, so you cannot draw a line of best fit, okay? So we can just put no line of best fit. Are we good? All right. Number 2. Okay, so this table shows the value of Heather's portfolio in thousands of dollars at the end of each year. Okay, so year 1, this means what, $90,000, right? Okay, so let's go ahead and plot these points. So year 1, her portfolio has 90,000. Year 2 has 70. Year 3 has 80. Year 4, 60. Year 5, 80,000, and year 6 has 60. Okay, so you have a ruler, right? So with your ruler, you want to draw a line of best fit. So you want to draw the line where it's, remember where most of your points are, right? Kind of, maybe like right here in the middle there. And let's see if we can get something similar. Maybe kind of right there. Were you with that?
Yeah.
Okay. You kind of want it to best represent your data, the trend line. Okay, so that's going to kind of help us predict. In part B, it says we're going to use the line of best fit to make a prediction about the value of Heather's portfolio at the end of year 8. So year 8 is right here. So we can predict about what? 50, 40. Yeah, the way mine is kind of is right. Actually, it's pretty close. Arrow. Yeah, it's really not a straight line. But I like that I heard 50. Yeah. I like 50,000. Let's see. 150, 140, so any range between, of course, this isn't what, thousands of dollars, 50 to 40,000 is fine. Okay, when you're assessed, you're gonna have answer choices. Are you good with that? Okay. Are both of them reasonable, you think?
Yeah.
Okay. Because we wouldn't have picked like 90,000 or 10,000, right? They're pretty far apart. Okay. All right, so turn it over to the back. I want you, with your table, to try number 2, and then we'll see how you do. Haley has a leaf breaking company to help offset school costs. The table shows how many bags of leaves Haley was able to fill each hour. Use the information in the table to answer exercise 1 and 2. All right, so we're gonna construct a scatter plot. So at 1 hour, 3 bags, 2 hours, 4, 3 is 5, at 4 hours. And you know each hour she should be having more bags, right? Yeah, so that should be a correlation, right? And at 5 hours, it's 14. Yeah, she worked really hard that last time. Okay. All right, then draw and assess a trend line. Let's see. Draw a line. Oop, I'm not sure if I used there. All right, use the line of best fit to predict how many bags at the end of 7 hours. Oops. And then draw a line all the way to the back. Make sure you draw your arrow at the all the way at the end of the graph. And it's 7 hours. I got about 16. What y'all get? 18. Anything else? I would say for sure not 14. So maybe 15. 15 seems might be okay. So between 15 to 18 is good. Did anybody get anything different? Okay, I got 16. Again, you will have answer choices. All right. Last example we'll do together. We have Cleo's baby pool has a leak. The scatter plot shows the amount of water left in the pool at the end of each 5-minute segment. Okay, so in our mind, you know, if the pool is leaking in the amount of time, that should have a correlation, right? And that should be negative, right? Because we're losing water. Good. We're going to use information in the scatter plot to answer number 3 and 4. They do want us to write an equation in slope-intercept form. So on your reference material, remember that's y equals mx plus b. And we're going to use that trend line to help us predict. Okay, so what is our y-intercept?
34.
Good. And our slope, remember it's a change in y. So if we can start here to here, right? And we're going to have to choose that point on the line. Are we good with that? And we're going to go down how many units?
3.
Is it?
Yeah. No.
Look at your intervals.
Oh.
10, 15, right? Do you agree we're going down 15 as a change in 15?
Mm-hmm.
Yeah? Okay, and then we're going to run, how many?
4. No.
Are we?
1.
Good. That is a change in 20. Be careful with your intervals. Okay, don't just count lines. Okay? What did we say, 20? All right, and that simplifies to what?
34.
Good, so a negative 3/4 is what I'm here. Are you good with that? We went down down, and that shows a negative correlation, right? So that means your slope is gonna be negative. Okay, so in number 4, we're gonna use this equation to make a prediction about the amount of water left in the pool after 40 minutes. Okay, so we should, you can see 40 minutes is here, right? There's our prediction there. But how can we use our equation? What is x going to represent? What does x represent? Look at your graph.
How much water needs to be?
Huh?
How much water needs to be?
What is our x-axis? What does that represent? Time. Good. So how are we going to determine 40 minutes? What are we going to have to do with our equation? If x represents minutes, time, and we want to know after 40 minutes how much water is left, this is your y, right? That's going to give us our answer. So what do we do with our equation? Yeah, we're going to plug it in. So in your calculator, you can put in negative 3/4 times 40 plus 35. So about, good, 5 what? You got it. And then we can see also here that that is a good trend line, right? All right, get out of the device and have a good hoot on scatter plots and trend lines. Make predictions.